Okay, welcome to another video by Technical Technician from Diagnation. Take a look at the your illustration. What I'm going to call this video is Honda VTEC, oil pressure in the scope. Honda VTEC, VTEC an acronym from Honda, which if you look at Honda service information, stands for valve timing and electronic lift control. This is a system that's PCM controlled that will send, when commanded, will send oil. As you can see your illustration, the oil pressure comes up. It would go to the VTEC solenoid, which is power side switched from the PCM. It goes through a switch. That's a VTEC switch. That's a validation switch that the oil pressure got through the solenoid, and the voltage on the wire, as you see that PCM wire to the VTEC switch, will change state. It will go from low to high, would tell us that the natural state of the switch is closed. And when the VTEC solenoid opens, commanded by the PCM, that oil pressure switch will change state, and that voltage will go high, indicating that the oil pressure got through the VTEC solenoid on its way to the rocker shaft. And those, you can see there, that that's the oil pressure going into the rocker shaft. And those little squares are a depiction of those are like the lost motion pins that it moves, and it moves the rocker arm to actually get to follow a cam lobe with more flanker, more lift, and hence it will open the intake valves more. You'll get more of an opening. And then when the system is designed to stop working, the rocker arm, the lost motion pins will move the other way, and it will go back to the normal lift. So anyway, we have 4 channels here on the scope. We have channel A is a WPS 500. I am in the oil pressure sender unit hole. I unscrewed the oil pressure sender. You saw that in another video. I used a hose to go in there with a fitting, and then put the WPS on the end of the hose. If you haven't seen the setup, you can probably go to the Honda VTEC video, and I show a picture of that hose and how I was able to adapt into the oil sender hole to get oil pressure. Channel B is the crank sensor. Channel C is the VTEC switch, and channel D, yellow, is the current ramping of the VTEC solenoid. We're not going to look at VTEC solenoid voltage. Basically, we're going to look at current, because I think it's a better depiction of the movement of the solenoid to validate that it actually moved. And then as we look at oil pressure, we see the oil pressure get in there and affect the system, and it will cause the intake valves to open more. So basically, kind of analyze this illustration here, and let's go to the scope. And the capture has been done. I did it. I took it down the road and gave it throttle and recorded the capture. So this has all been done. Let's kind of get a look at our channels. We see the big thick one in red is the crank sensor, but let me get back. I'll give you okay. Let's go back to the beginning of the capture, and we'll talk about each channel. Okay, let's look at let's kind of get each channel one at a time and talk about it. We're idling in the beginning right here. We can see blue is our oil pressure. Let's look at the idling oil pressure. We're looking about 20, 24, 25 and change on that. Our current is low. It's not flowing through the VTEC solenoid. Our validation switch most likely will be closed because its voltage is low. That will change as we get into this capture. I just want to talk about one thing right before I do this. Will help us. I'm going to make a math channel. It's going to be sort of, I use this in other videos. It's going to be a frequency channel, but it's going to be sort of in its own way. It's going to be an RPM channel, because it's going to follow as if we had a true RPM math channel. It would, as far as shape, it would be identical. As far as specific number, no, we can determine RPM from the crank sensor, and I'll show you that. But let's go and get a math channel from Tools, the math channels, and I have this is frequency B, which is the red channel. Now we have an RPM channel. We have some frequency. It will get more definable as I go on. Let's go down to the next capture, and we can start to see some change here in our RPM, because we see our math channel. It's sort of a burgundy, sort of purple, and you can see that go up. This we'll have to deal with. That's just the encoded portion of the crank sensor. Nothing I can do about that. Just look at the bottom section right here. This is kind of like RPM, and you can see it sort of corroborates with oil pressure, because oil pressure is going up and RPM is going up. We can see we're probably giving it some throttle here. Yeah, we got some wind blowing, and we come up here, and then I took my foot off the gas. We did not have any VTEC action yet. That takes a little bit of a substantial amount of RPM to activate. But nonetheless, let's see how far I got without the VTEC being actuated. Let me go to the top of my my RPM crest right here, and I'll take an RPM reading just from the crank sensor. This is kind of I'm just going to look at a rotation and determine RPM. Let me get that back. Okay, this is the top, and I'll go right to here and get rid of that guy and go from here, and I'll just measure 1 revolution and see what the RPM is. Okay, that's not correct. I did something wrong. Let's go back to another section and get the RPM. Okay, I'm sorry. I probably had it right. I'm thinking of idle. That's about 2,066 RPM, which not enough to get the VTEC activated, but that's about $2,000, which is something. And obviously the RPM descends here. My foot comes off the gas. Our oil pressure is going down, and we'll take well, I don't want to waste time with getting another RPM. That's probably an idle RPM. Then we can trust our measurement. So that was about 2,000 RPM at the top of this peak right here, at this top of this math channel. This might have been right here. I'm going to mention something. I'm going to say that's the pressure relief valve in the oil, about 90 PSI activating. You can see a little drop there from 90 down to low. It may it may dump off some of that pressure just from the look of it. It looks very abrupt. I don't think there's anything else that could have caused that, but nonetheless, oil pressure tells a story about certain situations. So we'll keep going down the line. Let's go to the next capture. Right here we have some action. Okay, let's kind of we see the RPM going up. Right, we see oil pressure going up. We see our section where what I surmised was the oil pressure relief valve. But let's concentrate right on here. First of all, let's get an RPM count. Let's see where we are as far as right when the moment the solenoid, the PCM commanded the solenoid open to get the oil flowing to the rocker shaft to activate VTEC. I'm curious what that RPM is going to be. I'm going to go here, if I can see this, to here. And we're about 2206. So as far as RPM, so it's probably about the threshold where the PCM decides to activate. There's other variables involved. It's got load and things. There's a bunch of things the PCM's looking at, but nonetheless we can tell this is a direct validation that the PCM opened the VTEC solenoid, and of course we see the pintle hump means our solenoid moved. And there's one thing I want to point out. You can see right here, you see that little drop right here. That's a pretty good drop. Now if you look at your illustration, I gave it some thought. That rocker shaft, that takes on a lot of oil volume. That's a pretty, if you're taking the Honda, done work on the cylinder heads, that's a long, kind of a tubular tunnel above the valve train that takes on that oil pressure. That's oil volume. So as we can see on our oil pressure, right before when the VTC solenoid opened, look at the change in our oil pressure. That little drop there. That tells us something. That tells us something. That oil got up and through there. That oil got into that rocker shaft. We got a little delta there of about 15 PSI. So that's again, anytime we're dealing with VTEC or VVT or oil, or even transmissions, when we see a little dynamic pressure change like that, right at the moment a solenoid moved, that tells us that oil got through there. So we could, say we have a good oil flow, we have a good oil galley. So nonetheless, we definitely can see all the action reaction of the VTEC solenoid. The switch right here, of course, the switch went high because it opened up. at 12 volts right here, as you can see. RPM I won't look at anymore. The RPM, the math channel, that's our frequency channel, which basically is an RPM channel, and oil pressure going down and current going through the solenoid. So basically we can see the action reaction of everything. And let's take a look at another portion. This is right here. Now what happens here is it actually closes the solenoid and says no more VTEC, and it shuts the VTEC system off. And as we can see, our RPM is descending, it's getting lower. Our switch change state, our PCM gets to know about that it happened, that the oil pressure went away from the rocker shaft, and our solenoid is closing. A little reverse pintle hump there, I can't explain that. You know, it's like a fuel injector, but nonetheless. Take a look at the, I'm gonna give some vertical zoom to the oil pressure and see that what happened here. See the oil pressure? Right at the moment the solenoid closes, our oil pressure goes up again. So you see a little rise, in a sense, about 15 PSI. I could sense, let me get a delta measurement, how much it rose from here to here. Okay, that's about 15 PSI. That 15 PSI tells me that the pressures no longer there's no more of a volume loss anymore, because that rocker shaft would be a little bit of a volume loss for the pump. So it tightens up and it increases because it doesn't have to dump any pressure into that rocker shaft. So basically, that's the action reaction of the VTEC solenoid shutting off and closing off and getting the car back to the normal lift, not the VTEC lift of the intake valves. So basically, here's our oil pressure again, changing, but no VTEC action. We see oil pressure coming, descending. We see RPM descending. Any more? Okay, we can just kind of see. Okay, here we go. Here's it is again. You can see that again. Here's our solenoid opening. Our pressure, oil pressure dropping again, pretty clear. Dropping, our switch changing state, and of course our RPM is probably around 2200 RPM. And so basically that's our VTEC in a nutshell. And one more shot right here. You can see that swing, that downward swing in oil pressure as the solenoid opened up. But anyway, just want to talk about, be mindful when you get VTEC situations. You don't have to do this hookup immediately. It's pretty good validator because it's direct information as opposed to process information from a scan tool. Scan tools are good though; they give good PIDs, but just be mindful of that. Of course, oil pressure and oil level. The first thing you want to do is jerk that dipstick out and look at it. The oil's got to be the right quantity. It's got to be clean too. That is super important with the VTEC system to perform right. And also the VVT, the variable valve timing system, to perform. Anyway, this is Technical Technician signing off, and take care and all the best.